Greetings to you, ladies and gentlemen. We meet for yet another discussion on measures of central tendency. Measures of central tendency is a discussion or a topic that we find in quantitative methods. We are looking at quantitative methods 1. Specifically, we will focus on how we calculate the mean, the median, and the mode of both ungrouped and grouped data. Then we'll focus on how we calculate quartiles and interrange. So my details, in case you want to contact me, are as shown on the slide. Let's look at what is a measure of central tendency. In some cases, the analysis of certain individual items in the data set is of more interest rather than the entire set. So we'll be wanting to focus or to pay much attention to a few elements in the data, not the entire data as well. So we might be interested in the average, we might be interested in the 25% lower quarter or upper quarter. This is all what we're talking about, measures of central tendency. We're saying how far are we, how is this portion of the data that we're looking at far away or related to the entire data in the given set. We don't necessarily need to look at the entire data, but we're just focusing on a few areas in the data provided. Now, in statistics, a central tendency or a measure of central tendency is a central or typical value for a probability distribution. It may also be called a center of location or a center or a location of the distribution. And like I've said, we specifically focus on the arithmetic mean and the median and the mode. So we shall be looking at some of these variables. Now, before we get to that, I want us to look at the concept of grouped data. What is it that we call grouped data? Grouped data is data that has been grouped together in categories. The data is grouped together by classes. It is shown in the form of either histograms or frequency tables, you name it. An example could be the relative frequency histogram showing, for example, book sales for a certain day, or grouped by price, or a frequency table showing grouped data of persons by height. Now, I want us to look first at how we can calculate the mean. Now, here's an example of grouped data. When you look at where I put classes, these are the classes that we're talking about. Now, you can see we've got number of orders. The example here says the table is showing a number of orders received each day during the past 50 days at the office of a mail order company. And we are required to calculate the mean. How do we calculate the mean under the circumstances? Right. The data is grouped, like you can see. We have ranges given there, or classes. 10 to 12, 13 to 15, 16 to 18, 19 to 21. Those are our classes or categories. And the data has been grouped. These are what we call groups as well. Now, if you look this column. In this column, we have got the frequency of the orders received, right? So what will be required here is to identify the mean. What I want you to take note of is when you add up these numbers, they add up to 50. So 50, N is representing the totality of the occurrences, that is the orders that have been made. Now, our task right now is to calculate the mean. How do we go about calculating the mean? Now, we have got the frequency. The first thing that you do is we need to find a number that we'll use. If you look at our classes, from 10 to 12, we need to find the mid part of that group or category. Now, we find it by adding these two numbers, the lower boundary limit and the upper boundary limit. If we say 10 plus 12, then we divide by 2. That will give us the midpoint, which I will call X here. Now, if you say 10 plus 12 is 22 divided by 2, we get 11. And we say 13 plus 15, we get 28. If we divide by 2, we get 14, and it's so on, so on. Now, this is the mid part of the point. So x, like I've indicated here, it's representing the midpoint of the class, which we get by adding the class limits and dividing them by 2. Having done that, now this will be representing, instead of having a group, we are now representing these classes or categories by one number. So 10 to 11 is represented by 11, 13 to 15 is represented by 14, and so forth. Now, in the fourth column here, what we'll do is we'll multiply the frequency by the midpoint. If we say 4 multiplied by 11, we get this 44. If we say 12 multiplied by, we get these numbers. Then we add the total, we get the number here, which is 832, which you can see here. Now, so since all these numbers we were multiplying, frequency by midpoint is the summation. This sign, which is indicated here, shows the summation. So the summation is 832, and n is representing the total numbers of the frequencies. Now, here's what we do. This sign x bar is representing the mean. Now, what we'll do, we'll take this 832 and we divide it by n. So our formula becomes summation fx divided by n, and if we were to substitute into the formula, taking the numbers that we already have, we have 832 here divided by 50, and it will give us 16.64. That becomes our mean. Now, so it's as simple as that. I want us to move to the other variable that we want to calculate here, the median. And what is the median? It is the numerical value separating the higher half of a sample, of a population, or a probability distribution. So we are given an array of data, and we are saying what is the middle part of that data. It will be very easy if the data is ungrouped, but here we want to focus on grouped data because that's where most of us sometimes face challenges. We have got a formula that we use there, and the formula is median. We get it by L base M plus N divided by 2 less F divided by F base M. Now, let's understand these variables, what they mean. N is the total frequency. F is the cumulative frequency before the class median. And Fm is the frequency of the class median, whereas I is the class width, the interval, and Lm is the lower boundary of the class median. Now, how do we go about calculating the median? Okay, we've got 3 steps that we must follow. The first one is we need to construct the cumulative frequency of the distribution. Okay, we are given this is the frequency. So we'll need to come up with another column and calculate the cumulative frequency from this given data. This is our given data, the classes or range, then the frequency. Now, second, we have to decide the class that contains the median, that is the middle class. Then we find the median using the formula that we highlighted earlier on, that formula. Median plus is equals to that blah blah. Okay. Now, let us do our cumulative frequency. Here is our cumulative frequency. Simple. We are just saying, right, 8, right, plus 14, it gives us 22. That's how we are getting our cumulative frequency. So this is our cumulative frequency. You will find that at the end of the day, the last digit that we have here, the cumulative frequency is 50, which is equal to n equals to 50. Now, having done that, we will need to find the median is the middle part of those numbers. So how do we get them? If this is the cumulative, we simply divide n divided by 2, which we have done here, and we'll get 25. So 25 is the class median. right? Class median is 25. What it means is we need to look, when we go back to our cumulative frequency column, where we find our 25. If we get to 22 here, we don't have, we've not reached the number 25. But somewhere here, this is where we find our median. So it's in the third category. If you count from here, 1, 2, 3. So this is the class where our median is supposed to be. Okay. Now, remember our formula, okay? If we go back, our F is the frequency just before the median class, the cumulative frequency. You find it's 22. So it's denoted by F. F becomes 22, the cumulative frequency just before the median class. Then we have got FM equals to 12. FM represents the frequency of the where we find our median class. Our median class, we said it's in this group 21 to 30. So we look at the frequency for that, it's 12. That's where we're getting our 12 here. Then we find the LM. This is the lower limit of the median class. We know the class where the median is this one, and our lower limit is 21. Here is one thing that you do. I've put here 21 for simplicity, but you define that between 20, right, and 21, we've got a difference of 1. So the easiest thing could be, you say 20 plus 21, you get 41, you divide by 2, then you get 20.5. So we could have used here 20.5, but for simplicity, since to the nearest it goes back to 21, I've just used the 21 in this case. And our interval is 10, as you can see when you subtract those two. Now, let's go back to our formula. Okay? Our formula, as you can see, okay, right. We've said the median, right, is 20. Is median is equals to LM plus N bracket N divided by 2 minus F, capital letter F, which stands for the cumulative frequency just before in the class, just before the median class, divided by the frequency of the median class. All right. From our variables, you see we have said we are taking these variables here. Okay. These are our variables. So we're taking F equals to 22. LM, we know it's 21, so we substituted by 21. Let me just slide back to that. LM is 21. You can see on the slide there, here is our LM representing, substituting this one. Okay, then we have got N divided by 2. Remember, N is 50. As you can see there, if we divide 50 by 2, we get this 25. Now, we're saying minus F. F is the cumulative frequency in the class just before the median class. And we see that it's 22. When you look at our second class there, it's 22. That's the cumulative frequency. So that's where we got our 22. Then the frequency of FM, the frequency of the median class. The median class is the third row there, where that is 21 to 30. The frequency there is 12, and we put our 12 there. Then the I at the end is the interval, which is the 10. So we solve this. Okay, if we say 25 minus 22, we get 3. All right, 3 divided by 12, we get 1 over 4. 1 over 4 multiplied by 10, it's equals to 10 over 4. If we say 10 over 4 plus 21, you will get the number that we have here. So what does that mean? It means when you look again at our data, it means 25 persons take less than 24 minutes to travel to work, and another 25 persons take more than 24 minutes to travel to work. That's what we mean by that. Now, I want us to go to what we call quartiles. What do we mean by quartiles? Right, quartiles are the 3 values that divide the data set given into 4 almost equal parts. Let's say we've got numbers, 100 numbers. 100 numbers, they may be 2, 4, 7, you name it. But what will happen now is we arrange these numbers in sequential order and we divide them. Since they are 100, each quarter we have 25 members or elements. That's what we simply mean. So if we arrange this array in sequential order, we're simply saying at the end of the day, how big, right? The first quarter of those numbers, of that array of data, should have 25 points. The second quarter, the same, because we've got 4 25s in 100. Now, so quartiles, we've said they are the numbers that say the values that separate the given data into 4 equal parts. Now, we've got the second quartile. The second quartile, it means 25 by 2 out of 100, which means it's 50%. In this case, the first quarter, Q1, is 25% of the data given. That's the first quarter. Then the second quarter is equals to half, which is Q2 here. And the third quarter becomes the Q3, 75% of the given data. That's what we simply mean. So this is what we have also indicated here, dividing the data into those 3 quarters. Now, I want us to look at this example. Let's say we are given this data. Right. If you look at these numbers, they add up to 30, right? If you check 1, 2, they don't add up to 30. There are a total of 30 different numbers given here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Each row is 10, so times 3, they'll give us 30. We've got 30 numbers given there. And if you look at these numbers, they are not arranged in sequential order. They just were slotted there haphazardly. But we are required to find the first quartile, the second quartile, and the third quartile of that given data. Now, here's how we go about calculating the first quartile. Okay. If you look at our data, in the first illustration, the data was just haphazardly put on that table. Now, we have arranged it in sequential order. Okay. So, the first task to do is to arrange your data into sequential order. Those are marks that were scored by 30 students in class, and the test was marked out of 100. So they got those various scores in the test. Now, we have arranged now, you will find that they fall in sequential order, 44, 56, like that. Okay. Now, finding the first quartile, we know that the first quartile is 25% of the total numbers given. 25% is the same as 0.25. Now, if you said 0.25 multiplied by 30, this 30 is coming from these numbers if you add all of them, right? If you count them one by one, there are a total of 20 different numbers, 30 different numbers. So we want to find the 25%. 25% here, we've said 0.25 multiplied by 30, the total numbers, will get 7.5. What does that mean? Right? We round this one to the nearest, it gives us, we round it up, it gives us 8. This 8 simply means that the 8th number in this array of data is what we are interested in. That becomes our first quartile. If you count from here, if you count 1, 2, 3, 4, 5, 6, 7, 8, you get to 72, which I've circled here, right? So that number is our first quartile. So what it simply means is 25% of the scores scored by this class of 30 were below the mark of 72%. So it's as simple as that. Let's go and calculate the second quartile. Okay. So that's what we're discussing there, right? Calculating the second quartile, we are using the same what? The same method. Okay. We know the second quartile is equal to the median, it's equal to 50% of our array of data. Now, here's what we are doing. If we say 50%, we know it's 0.5, and we know the total number of elements here is 30. If we say 0.5 multiplied by 30, here, this 30, I've said it's these total numbers indicated. So, it will give us what? 15. What does this 15 mean? It means we have to look at the number in the 15th position after we have arranged this data in sequential order. Now, if you count our numbers, right? You count, we have said this one is 10, right? This one is what? It's 10 as well. Okay, so here's what we'll do. When we count this number, you will find that, let's count. The first one is 10. Then we count here 11, 12, 13, 14, 15. I think I made an error somewhere there. That is our 15th number. Now, if you look at this number, right, if you go the other side, okay, we also have got 15 numbers. 1, 2, 3, 4, 5, 6. Okay, the 10 below plus this 11, 12, 13, 14, 15. Right. So what it means, we've got our dividing line is somewhere there. That's where we get our number. But now we've got 15 this side and 15 the other side. 15 going this side and 15 going this side. So what we need to do, we need to add these two, right? 78 and 79. Then we divide by what? By 2. Now, the simplest thing that you can do is that you can add this and this, you divide by 2, but we know very well that the difference between 78 and 79 in this case is just 1. So you just get the 1 divided by 2, then you get 0.5. You add the 0.5 to 78. Or you just add the 2. 70 plus 70 is equals to 140. 8 plus 9 is equals to 17. So 140 plus 17, it gives us, am I right? 70 plus 70, 140. 8 plus 8, that's 16. That's 156, 157. 157 divided by 2, it will give us 78 divided by 5, 78.5. That becomes what? Our median or second quartile. So the average of the 15th number and the 16th number, this is the 15th, right? And the 16th, we add them and we divide them by 2 to get the median or the second quartile. And our answer for the second quartile is 78.5. We go to our third example, calculating the third quartile, Q3. We look again at our array of data as given, arranged already, and we've said third quartile is equal to 75%. 75%, which is 0.75. The total number of units is 30, so it becomes 0.75 multiplied by 30. And this will give us 22.5. When we round this 22.5 up, it gives us 23. So we have to focus on the 23rd item. The 23rd item is one that represents the third quartile. Now, if you count here, it's 10, 20, 21, 22, 23. So 88 is the number that we're interested in. So 75% of the scores were below 88%. That's how we calculate our quartile. That is ungrouped data. It's so simple. Now, we look at how we can calculate the quartile when we have got grouped data. Now, earlier on, you remember calculating the mean. Okay, we are going to use the same method, not the mean, the median, the formula that we used. Where we have got Q1 here, initially we had an M, if you remember, and where we have got FQ1, initially we had FM. Now, this N stands for the total frequency as in the past. F, cumulative frequency before the first quartile class. FQ1, the frequency of the first quartile class. And I, the class with LQ1, the lower boundary of the quartile class. So if you look at this formula, it's just the same is the one that we've used. These are two formulas. This one, we shall look at it when we're calculating the third quartile. So for the first quartile, we're just focusing on this one. But if you look at them, they are the same. The only thing that has changed is the denotation here. It's 3, Q3 now. So if it was the second quartile, we would put LQ2 just like that. Okay. Now, let's have an example by people to travel to work. Okay. This is the given data. And based on this, we would like to calculate the quartile and the interquartile range of this given data. Okay. Now, here is what we will do. Step 1 again, you remember, we calculated the cumulative frequency. Okay, there we are. Frequency, and we now know how to calculate the cumulative frequency, just adding this 8 goes there, we add the next frequency, it gives us frequency. Let's go to our formula and to see how we can come up with a solution to this. We want to determine Q1 and Q3. The class Q1, to get that one, we have to divide the total number of elements, which is in this case 50, and we divide by 4, since we said the numbers, the array of data should be divided into 4 equal parts. So it means each quarter, the first quarter, it should fall in position 12.5, which is roughly 13, but we may leave it like that. So the first quartile class is the second class. What do I mean? If we go there, we are looking at the 13th number. The 13th number, we find it in the second row, the second class, because if you see cumulative frequency, after 8, the last column there on the slide, after 8 we get to 22, right? But we're looking at number 12.5 or 13, rounded up. So we'll find it in the second row or second class. Now, having known that, we now know our class Q1 class or first quartile class, which is Q1, which is that second one, because that's where the 13th position lies in. Now, LQ, you remember we said LQ is the that lower boundary of that class, which is in this case 10. Like I said, here we've got our lower boundary, it's 11 in the second class, but we've got 11 in the previous class, 1 to 10, the upper boundary, it's 10. I've said you can take 11 or then you get 10.5. That's what we've used this time around. Now, that being the case, so our LQ1 becomes 10.5, which we got by adding the 10 and 11 and dividing by 2, 10.5. Our N we know it's 50, right? N divided by 4, we already know it because we calculated it somewhere there. Therefore, it gives us 12.5. So this 12.5, we have brought it down here to our formula. Now, this 8 stands for the cumulative frequency just before the first quartile class. In this case, is the first row, which is 8. That's why we put this 8. If you look on the last column on the slide where we've got 8 there, that's where we are getting the 8, the cumulative frequency there. Now, this 14 that we have here is the frequency of the quartile class, first quartile class, the second row there. The frequency there is 14. That is, if you look at the class 10 to 20, our frequency is 14, which is represented. So it comes here from here, it goes there. Then our interval is 10. If you say 20 minus 11, there you get the 10 that we're talking about. Okay. Now, we calculate this, we solve this, then our answer becomes this one. So this is our first quartile. Our first quartile is 13.7143. Okay. Let's move forward to calculating the third quartile. Okay. The third quartile is the same formula, right? The only difference that we are doing here, we are multiplying by 3 there, divided by 4. We know already it's just the n is 50, and the 3 simply means the third grouping of data. So it's 3/4. If you say 3, what we mean. So we could simply say 0.75 multiplied by 50, it will still give us the same, right? So that's what we have done here. So this one is 1/4 of n, 75% of n, which is 75% of 50. It gives us 37.5. So our class, where we find this number, where do we find it? Let me go back slightly here. Right. We find number 37.5 or 38. I think we'll find it in the class range 31 to 40. 31 to 40. That's where we find number 35 when you look at our cumulative frequency. Okay. Now, if we look at that row now, our LQ, which is the lower limit there, it becomes 31, or we add 30 plus 31 divided by 2, we get 30.5. That's how we got to this 30.5. Now, here n divided by 4, we know this already. N divided by 4, it's equals to 37.5. Am I right there? Okay, we should have multiplied this one by what? By 3. Okay, so we get this 37.5 that we got there. We subtract now the cumulative frequency of a class just before the third quartile class. We have said our therefore a class just before that, it's that one of 21 to 30, and the cumulative frequency there, it's 34. That's where we get this 34. This does not change. Our interval remains 10. 9, this is the cumulative frequency of the third quartile class, which is 31 to 40 class. We have got 9, we put our 9. Then we calculate this and we get our, we get our third quartile, which is 34.388. Now, I want us to see now how we calculate the quartile range. The quartile range is something that it's simply calculated by Q3 minus Q1. From our calculations, we got our 3Q is 34.388 less 13.741. So we just calculate, we subtract this, then we get our quartile range. Okay, ladies and gentlemen, thank you very much for your attention. I hope I find you well. Next time, ladies and gentlemen.